So last starter on this section, given f of x equals 4x squared minus 8x plus 3, find the domain given there is an inverse function. So the prompt in the question is, there is an inverse function. If there is an inverse function, if inverse function, this means f of x must be 1-to-1 for the given domain. So if we think of a quadratic, the graph has got this shape. So for it to be a 1-to-1 function, doesn't really matter where the axes are. Yeah, for it to be 1-to-1, we either want to go from the lowest point, so that's the turning point, either this way. Yeah, so if I called that point there, x has got to be greater than or equal to a, or this way, where x is less than or equal to a. It's that or that. What we can't do is have both, because as soon as we have points either side of the turning point, we end up with a many-to-one kind of function. So that point there and that and this point here gives the same output. And that makes it many-to-one, so there would be no inverse. We couldn't necessarily get back to where we started. Okay, so first of all then we need to find the turning point. That's the key thing from this question. So we could use differentiation or we could complete the square. 4 lots of x squared minus 2x plus 3 over 4 equals 4 lots of x minus 1 squared minus 1 plus 3 over 4, multiply through by 4, so we get 4 lots of x minus 1 squared minus 4 plus 3 is minus 1. So the turning point is at 1 minus 1. Therefore, domain for f of x, the input values, is either x greater than or equal to 1 and x is a member of the set of reals, or x is less than or equal to 1 with x is a member of the set of reals. Either of those domains will enable us to have an inverse function.